Hello, this is Mr. Knowles, and this is a video to help students at home or parents with their assignment that went home this week. It's titled Section C Practice Problems. This is the third section of the math unit. We're learning about comparing fractions. So let's get started. I'm just going to zoom in on my paper really quick. Number one, for each pair of fractions, decide which fraction is greater. Explain or show your reasoning. In class, we've been using different strategies to explain our reasoning. We've drawn pictures, we do it mathematically. So I'm looking at that first problem, 2/5 or 2/6. You could try to draw a picture. So like 2/5, for example. I try my best to make fifths. They're a little challenging sometimes. Doing my best there. And I would shade in two of the 5. Kind of looks like that. And now I'm going to make 2/6. It's going to have 6 parts. So I always like to make thirds, kind of think about thirds, and then I try to extend it out. But you can do it however you want. Then I would shade in 2 of the 6. And my drawing's not really accurate, so it's kind of hard to tell. So maybe I do an equivalent fraction really quickly. I'll just do that down here. So if I make a fraction with a common denominator that they both have in common, I know 30 will work. And if I times 5 by 6, I get 30. So then if I times the numerator, the 2 by 6, I get 12. And then the other fraction, 2/6, if I times 6 by 5, I get 30. So 2 times 5 is 10. Oh, I noticed that these are larger. So that means 2/5 is larger. Some students will say that fifths has less pieces, so the pieces are bigger, which is true. That's another reasoning there. So they could say fifths has less pieces. There's 2 of 5. That would be larger than 2 of 6. Because if you had the same whole thing cut into 6 parts, the pieces would be smaller. They could do that as well. Letter B, 5/8 or 7/8, since they have the same denominators, that hopefully makes things a little easier. And we can just look at the numerator, the top number, and decide, oh, 7/8 is bigger than 5/8. 9/10 or 103/100. Well, I know that 100/100 is a whole thing, so I know this one is larger than 1. Larger than 1 whole. And I know 9/10 is less than 1. It's not complete yet. If I wanted to convert that or change 9/10 into a equivalent fraction, I know that's the same as 90/100. So this one's larger. Moving on. Lots of strategies that we've learned in class to figure these out. Use the less than, equal to, or greater than symbol to make each statement true. 2/3 or 10/15. Well, I am going to take 2/3 and make it mathematically into 15ths. And I believe if I times 3 by 5, I get 15. So let's times the 2 by 5 to make that equivalent fraction. So that's 10/15ths. So I can use this equivalent fraction to help me compare. Now they're both in 15ths. They're equal to each other. All right, let's just do that. The next one, 1/5 and 22/100ths. Wow. I'm going to do something a little different. I do know 22/100ths is the same as 11/50ths. And I know 1/5, if I were to make that into 50ths, I could times it by 10. So if I times this numerator by 10, I get 10/50ths. Oh, that 11/50ths is definitely bigger. So I'm going to use this symbol here. Last one, 10/4ths or 45/20ths. Wow. That one's interesting. I'm going to make the 10/4ths into 20ths. I'm going to make an equivalent fraction, so I'm just going to times the 4 by 5. Then I'm going to times the 10 by the 5. So that's going to become 50/20ths. So this is also equivalent to 50/20ths. And 50/20ths is greater than 45/20ths. So that means 10/4ths is greater than 45/20ths. Moving on. I hope this has been helpful. There is a water fountain 7/10 mile from the start of a hiking trail. There is a pond 3/5 mile from the start of the trail. If a hiker begins walking at the start of the trail, which will they come across first, the water fountain or the pond? Explain your reasoning. I'm gonna make a number line. This is the start of the trail. Over here on the left, this is the end of the trail over here. In math, we would say this is 1. We completed the whole thing, which is the trail. We don't usually talk about trails. And then 0 would be the start. And I see there's 7/10, and I see there's 3/5. I think I'm gonna make my fifths first the best I can. Fifths are kind of tricky to make. There's 1/5, 2/5, 3/5, 4/5, and this is gonna be 5/5. So then this is 4/5. This is 3/5, 2/5, 1/5. I'm just kind of labeling my number line there. And then the 3/5, this is 3/5. I'll use my red there. That's 3/5. Okay, right underneath, I'm gonna copy this number line, okay? Just gonna copy it. I'm gonna copy those fifth lines as best as I can. And I know if I cut those fifths all in half, I will have tenths. Now remember, this is 0. That's the beginning, and remember this is 1. That's when we completed the whole trail, the whole thing. That's 10. We're in tenths now. So I'm trying to find 7/10. So I know this is 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. Do I have to keep doing this? I can, but I already found where 7/10 is, and this is 9/10. So then 7/10 is right here. It looks like the pond, we would reach the pond first, except I don't have any more room to write. I'll write it up here. We would reach the pond first. My thinking is down below. Now, could you use another strategy like make an equivalent fraction for 3/5? Yeah, you could do that. You could take 3/5 and change it to tenths. I think you could do that too to help with your thinking instead of drawing the picture. Oh, it's the same as 6/10, and then oh, I would get to 6/10 first, which is also the pond. Lots of ways to solve that. Next problem, number 4. List these fractions from least to greatest. Explain or show your reasoning. Wow. Okay. Well, 1/3. 1/3 kind of looks like that. And I would color it in. I'm just trying to draw a picture of this to see if that helps me. This would be 1/3. That would be a third. If I were to draw 12ths, now it's getting tricky. 12ths are hard to draw. I always have my students draw like egg cartons. So if I were to draw an egg carton, because there's 12 eggs in a carton, and if I fill it in 5/12, looks like that. Ooh, it's almost half. It looks like it's closer to half than a third. So I'm going to say that one's bigger. And then 2/10. 2/10. If I drew like an egg carton, but it only had 5 parts, or 10 parts, let me do fifths first, and then break up 2/10. That seems like it might be the smallest. Now my thirds is a little weird because it's a circle, so if I were to change that really quick, make it the same size rectangle, and I tried my best to make it into thirds, and then shade that in, or maybe I do egg carton style, which I could do this. And what's 1/3 of an egg carton? Oh, 1/3 of an egg carton, I believe, would have 4 eggs in it, so it kind of would be about that big. Oh, it's smaller than 5/12. Now remember, this is in 10 pieces. But boy, that 2/10 looks the smallest. So that's what I would think. I would say 2/10 is less than 1/3, and that is less than 5/12. There's probably some other ways to do it. Number 5, I'm going to let you try that on your own. See what you come up with. Maybe you have a strategy that will be successful for you, but I bet you could figure that out. It looks like they're all greater than 1. So that's a start there. Well, best wishes with you. I hope this helped.